question 14 asks us to look at the intersection of these two lines. We're given some angle measurements and we're asking to find the value of each variable. Be very careful what you have here. These two angles here look like they're reflections from each other, so they're vertical angles. Since they're vertical angles, I can technically set up this equation. 120 degrees, this angle has to be congruent to the other angle of 2x minus 10. If I can solve for the x value, that would give me my value. So 120 plus 10, because I added 10 to both sides, that is 130 is equal to 2x divided by 2 divided by 2. The left side cancels, leaving you with just an x. This is 130 divided by 2. That gets me 65. So the x is 65. That is the value of the variable. Here, these two angles are not reflection from each other. They look like they make this line. So we call this a linear pair. Since they're a linear pair, we can add them up and set them equal to 180 degrees. 2x plus 4x plus 108 has to be equal to 180 degrees. 2x plus 4x is 6x plus 108 is equal to 180 degrees. Subtract 108 to both sides. This cancels, leaving you with a 6x is equal to 180 minus 108, and that is 72 degrees. Divide 6 to both sides. I get x is equal to 72 divided by 6, which is 12. So x is equal to 12. All right, now let's take a look at C here. Well, we need both x and y here. All right, let's see what we need to solve first. Okay. It looks like these two are vertical, so we can set those equal to each other and solve for that y value. 8y minus 102y is equal to 2y plus 6. Okay, let's solve for y. Minus 2y, this cancels. This gives you 6y. Minus 102 is equal to 6. Add 102 to both sides. This on the left side cancels. 6y is equal to 108. Divide by 6, divide by 6. This cancels, leaving you with a y is equal to 108 divided by 6. That is 18 for y. Then we need to know what x is. Well, we see, well, again, because we set this up because these were vertical angles. Okay. Take a look at what the x value is here. This forms a straight line. This is going to be a linear pair. So those add up to 180 degrees. The 3x plus 8y minus 102 is equal to 180 degrees. We can solve for this because we actually know the value of y, which was 18. Okay, notice this is now one equation with one unknown. 8 times 18, it is 144. So 3x plus this becomes 144 minus 102 is equal to 180. These two are on the same side, so we can combine like terms. 144 minus 102, that is 42 degrees. So 3x plus 42 degrees is equal to 180. Subtract 42, this cancels. 3x is equal to 108 minus 42. That gets me 138. Divide by 3. I get x is equal to 138 divided by 3. So x is equal to 46. Here there were two variables. That's why I needed two equations. Let's look at question D here. Same thing here. Let's set these two equal to each other first, because again, these are going to be vertical angles. There are reflections of each other. So 2x plus 25 is equal to 3x minus 10. Let's solve for the x value. So I'm going to subtract 2x to both sides. The left side cancels. 25 is equal to x minus 10. Add 10 to both sides. The negative 10 and the positive 10 cancels, leaving you with a 35 is equal to x. This is useful because we're now to set up this equation. We notice that these two angles here do form a straight line, so these are going to be classified as linear pairs. Since they are linear pairs, we know that they add up to 180 degrees. The two angles we are referring to is y plus 3x minus 10. We can technically solve for this because we actually know the value of x. The value of x from the first equation is 35. So let's make that substitution. 3 times 35, that gets you 105. So y plus 105 is equal to 180 degrees. Minus 105 minus 105. This cancels. Y is equal to 180 minus 105. This gets you y is equal to 75 degrees. Oh, it's just 75. So there you go. You have to set up the equation, and using each equation, determining if they're vertical angles or linear pairs, you can solve for a missing variable.